Hello, my name is Franz Lucien and I'm a museum educator at the Intrepid Sea, Air, and Space Museum. Now, the Intrepid is massive, 913 feet long. That means that if you took the actual ship and you stood it up on its end, it'd almost be as tall as the Chrysler Building in New York City. If you took the flight deck and you cut it into 3 equal parts, you can almost play 3 games of football at the same exact time. And the entire weight of the whole ship is over 41,000 tons. Yes, the Intrepid is massive, but it did float in the water. Now today, it's stuck in the silt and the mud of the Hudson River, so it's not really going anywhere or doing too much floating. But at one point in time, the Intrepid sailed the Atlantic and Pacific Oceans during World War II, Vietnam, and the Cold War. So this ship actually did float in the water. And you at home are probably wondering, how can something so massive float? And that's actually what we're going to be talking about today. We're going to be talking about how something like Intrepid can float in the water. Now, in order to do that, we have this yellow ball. And this yellow ball is spongy, right? It's spongy. You guys can take a guess at home. Do you think that this ball will float? Or do you think it will sink? Well, let's see. When we put this in the water, it floats. But not only does it float, it actually carves out a space for itself in the water. This is called displacement. You may have experienced displacement if you've ever tried to put in ice after you filled up water to the top part of a cup. What happens to the water? It spills over the edges. This is because the ice displaces the water. The ice has mass, therefore it moves water out of the way. That's exactly what this ball is doing, and that's what the Intrepid does with its keel, or the bottom of the ship. Its keel is actually kind of like a triangle pointing down through the water, allowing it to cut easily through the water, allowing it to sit, kind of like it's sitting on a chair in the water. Now that's just one way that the Intrepid can float. Another way that we can get the Intrepid to float is due to what's inside of it. Now, inside of this spongy ball, there's air and there's foam. There's not much material inside, and that's why it floats. But for something like a piece of metal, that's one solid piece of metal, when we put this in the water, it sinks, even though it's smaller than our ball. Now, the reason why this happens is because inside of this piece of metal, it's jam-packed with metal. Unlike our ship, even though most of the Intrepid is made out of steel, it does have rooms and hangars and space that has air that allow it to float. Now, we can think of this as density, and that's what this means. That's what it means when we have lots of metal shoved inside of one space. This is more dense than this ball, right? Because there's more mass in a given volume, it's more dense. Now, is there ever a time where you want your ship to sink? Well, in the case of a submarine, you might want to. Submarines work like this. You can imagine that this bottle is a submarine. Now, if it's sitting in the water, it's going to float. We have to make it more dense, which means that we have to add water. And if we add water to our submarine actually sinks, right? Because it gets more dense. Now, a way that you can test this at home is by creating your own submarine in a bottle. And that's what we're going to do now. Now, in order to create this, all you need is a water bottle, a soy sauce packet, and water. Preferably warm water, because warm water is less dense than cold. All you need to do is take the soy sauce packet, put it inside of the bottle, fill it all the way up to the top with water, and close the cap. Once you do that, your submarine is complete. Now, to amaze your friends, all you have to do is squeeze the sides of the water bottle and watch the soy sauce packet go down. And then you release the sides, and you can watch the soy sauce packet go up. Now, the reason why this happens is because when we squeeze the sides of the bottle, the water is very stubborn. It does not want to move. The only thing in this bottle that can move is the little air pocket that's inside of the soy sauce packet. So when we squeeze on this bottle, that air bubble is actually getting smaller. It's changing its volume, which means that its mass is staying the same, so its density increases, and it actually sinks. When we release this, that air pocket gets bigger, which means that the volume is increasing, meaning that the density decreases, and causes the soy sauce packet to rise back up.